I am Larry Hatcher. This is Psych 302, Computer Applications and Data Analysis, and we're going to take a look at lecture notes, chapter 055, APA style for summarizing results in text. As is usually the case, note to my Psych 302 students, you do not need to download the dataset or perform the analyses described in these notes. You should simply use these lecture notes as a guide when you complete your exercise, which will involve a different data set. Guide overview. This guide focuses on three separate learning objectives. Number one, it shows how to modify the names of variables in a jamovi data set. Two, it shows how to copy a graph from the jamovi results panel and paste it into a Microsoft Word document. And three, it shows how to summarize the most important results from a statistical procedure in the text of an APA-style research manuscript. This is a particularly important lecture because I go over the basics of summarizing results in APA style. So you should give yourself a good amount of time to read these lecture notes, get familiar with it so you can do your exercise properly, and also be ready for the related multiple choice quiz, which will be a part of this unit. I am on page 1, moving to page 2, halfway down page 2. And our investigation, the Employment and Health Study. Imagine you've developed an instrument called the Questionnaire on Eating and Exercising. You've obtained usable responses from 238 participants. Overview of our current analysis. Dataset to be analyzed in this chapter contains just 4 variables. One is named employment, and it simply codes whether the respondent was employed versus not employed while in college. The other 3 variables are the study's 3 outcome criterion variables. You'll now analyze the data to investigate differences between students who are employed while attending college versus students who are not employed while attending college with respect to these criterion variables. The criterion variables are minutes, which represents total minutes of aerobic exercise that the student engages in a typical week. Diet, the extent to which the student eats a healthy diet consisting of fruits, vegetables, whole grains, and other nutritious foods. This is on a 7-point scale where higher scores indicate a healthier diet. And finally, health, the extent to which the student feels good, feels healthy, is relatively free of medical problems. It's also measured on a 7-point scale where higher scores indicate better health. Bottom of page 3, starting the jamovi application. The way you start jamovi depends on whether you're using the installed version or the online version. If you're using a Windows computer and jamovi is already installed in it, you'll start jamovi the way that you would start any application. Click the Start icon in the lower left corner of the screen. Scroll down to the J section of the resulting list of programs, open the jamovi folder, and click jamovi. That should produce the jamovi interface, which initially will look something like this. Finding and opening your jamovi data file. Now that jamovi's open, you'll use the jamovi file panel to locate the data file and open it into the jamovi spreadsheet. Page 5, I give some instructions. At the top left of the jamovi interface, select the File Air Vent icon. Remember that File icon is these 3 horizontal lines. We also refer to it as the Air Vent icon because that's sort of what it looks like. In the resulting file panel, select Open. In the resulting Open panel, select Browse. In the resulting Open dialog box, navigate your way to the drive where you had saved the jamovi data file. Double-click the name of that data file, and the data file opens in the jamovi spreadsheet. You're now ready to perform the tasks described in the following section. I am on page 6. We come to the first of our real tasks for this lecture, changing the names of 2 existing variables. In a previous chapter, we created a set of box plots for the variable named health, and the graph we created presented a separate box plot for the two groups of subjects coded by the variable called employment. In this chapter, we'll create a graph that's essentially identical to the graph created in the previous chapter, except we'll slightly change the name of the two variables prior to creating the box plots. Specifically, we're going to change the variable name employment so that it is instead employment status. We will change the variable name health so that it is instead current health. Changing the name of the employment variable. To change the name of the variable currently named employment, we must first open it in the Jamovi Data Variable panel. Here are the steps for doing this. If necessary, select the Variables tab to reveal the Variables ribbon. This is the Variables ribbon. You'll know you're looking at it if you had selected the Variables tab. Then double-click the name of the variable employment. When you click Variables, it'll show the name of all the variables in your data set. In our case, we want to double-click the name of the variable employment. This opens up the Data Variable panel for the variable employment. In this Data Variable panel for employment, the initial name for the variable is simply employment. Your job is to click the name employment if necessary and change the variable name so that it is instead employment status. Once you've made that change, select the upward arrow to close the Data Variable panel. We've changed the name of one of our variables, now the next variable, changing the name of the health variable. We repeat these steps to change the name of the variable currently called health so that it is instead named current health. If necessary, click the Variables tab so that once again you're looking at the Variables ribbon. We have the list of variables here, and here is the variable named health. Double-click the variable named health and repeat the preceding steps so that its name is instead current health. Those steps will not be illustrated in this guide. You simply replicate the steps you saw when we changed the previous variable's name, and you will change health so that it is instead current health. When finished, the variables that had been given the new names of employment status and current health appear here. We have employment status, we have current health, we have successfully renamed our variables. I am on page 9, toward the bottom of page 9. Come to our next task, requesting the box plot graph. We will now use the Jamovi descriptives procedure to create a box plot for the recently renamed variable current health. We'll request just one graph, but this one graph will include separate box plot for each of the two groups under this newly renamed variable employment status. I'm on page 10 toward the top of page 10. Select the Analyses tab if necessary to reveal the Analyses ribbon. From that ribbon, select the Exploration icon. And from the resulting menu that appears, select Descriptives. This reveals the Descriptives Analysis panel. This is our Descriptives Analysis panel. In that panel, move the employment status variable to the split by box. Employment status is here. We're not moving it to the top box. We're moving it to the lower box, the split by box. Simply select the variable name, click the right pointing arrow here, and it'll move it to the split by box. Also, move the current health variable to the variables box. This is current health. You select it, click this right pointing arrow, and it moves current health to the variables box. I'm on page 11, at the top of page 11 now. Names of the two desired variables should now appear in the variables box in the split by box. Current health is in variables. Employment status is in split by. If necessary, click the down arrow here to reveal the options available in the plots section. We want to request some plots and some options. If you don't see the options for the plots, simply click this arrow to the left of the word plots and it'll reveal these options. Check and uncheck boxes so that only these options are requested. One thing I'll point out, and when you first select boxplot, one of the default options is label outliers. This can be a useful thing if you've got outliers in your data set. You want to find out which observations are those outliers. But in this case, we don't want to find outliers. We just want to have a decent looking box plot that we could put in an article if we wanted to. So uncheck that. When you're done with this options panel, you should have checked only the boxes that I have checked here. As you can see, the requested graph is identical to the graph that was created in the previous chapter. Hang on, we should take a look at that graph, shouldn't we? I am still on page 11. Here's my graph. Page 11, bottom part of the page. This is the box plot that appears when you make this request. As you can see, the requested graph is identical to the graph that was created in the previous chapter, except that the vertical axis is now named current health. Is that true? Yes. The vertical axis is now named current health instead of just health. Horizontal axis is now named employment status instead of just employment. And sure enough, horizontal status, the horizontal axis is now employment status. These changes weren't terribly important in this case, but there'd be a lot of instances in which you have some kind of a short variable name here that is not going to make sense to your readers. And so you want to change that name into a more understandable name before you put it in a manuscript that's going to be published. And that's why I've taken you through the steps and showed you how to rename variables in this way. We move to page 12. Pasting the box plot graph in a Microsoft Word document. We have our graph, but it's no good unless we can put it in the document that's going to include our manuscript. So we now go through the steps of copying it from the results panel of Jamovi and pasting it into a Word document. Okay, this is the figure that we're interested in. If you're using a Windows computer, right-click anywhere inside this box plot graph to reveal the right-click menu. From the resulting right-click menu, select Group and then Copy. When you right-click inside this graph, it produces this menu, which has a couple of sub-menus that can be produced. You will want to select Group and then Copy. That will copy this graph onto your invisible Windows clipboard. I'm on page 13 now, at the bottom of page 13. You've now copied this graph into your hidden clipboard. Now you're going to paste it into a Word document. So open a new document, Microsoft Word. Press the Enter key a few times so that your insertion point is a few lines down from the top of the page. Right-click at the approximate location in the Word document where you wish to paste your box plot. This will produce another right-click menu. From this right-click menu, select Paste. Doing this might produce one or two different pasting options. If so, select the pasting option that you prefer and the one that gives you the image you want. Screen capture below illustrates the selection of paste, keep source formatting. Although it's fine if you use a different option as long as it gives you an okay looking box plot. So I'm on page 14 now. I had opened up a new Word document. It began being empty. I hit Enter a few times just to move my insertion point down. I right-clicked at about this location, and right-clicking produced this right-click menu. From the right-click menu, I selected Paste, this icon Paste. And voila! The image of the box plot now appears in my Word document. This image might be bigger than you want. If so, you can select it and then drag the corners to resize it. If these two headings appear on the Word page, you want to keep those. You can just delete them the way you would delete any text. I go to page 15. I'm at the top of page 15. Summarizing results in APA style. Our next task is to write a summary of the results from the independent samples t-test. And we'll write this summary in the very same Word document that currently contains the box plot figure that we just pasted in there. Jamovi results from the independent samples t-test. To prepare a summary of the results, we'll need some of the output we created in the previous chapter lecture labeled Lecture Notes Chapter 050 T-Test for Independent Samples. The output you created back with that unit is the output we're going to use today. One of the tables, at least that I'm going to use in my lecture, one of the tables created in the previous chapter was headed Group Descriptives. That table is reproduced again below. Here's a Group Descriptives table that I got when I did my t-test in the previous unit. The other table from the previous chapter that we'll need will be the table headed Independent Samples t-test. That table is reproduced below. Yes, you'll remember we did an Independent Samples t-test where the independent variable was whether the individual was in the not employed group versus the employed group. That was the independent variable, the grouping variable. And the outcome variable was current health, the student's self-rating of how healthy they were. And we did a t-test to see whether there was a difference between the not employed versus the employed students. This is our t-test output that we got back in that unit. I am on page 15 at the bottom. Example of results section for the current analysis. In the following excerpt, call-out numbers such as 1 and 2 have been added to identify specific results that'll be discussed in greater detail in the section that follows the excerpt. Okay, I have taken my means and standard deviations from the previous descriptives table. I have taken my t-test and related statistics from the independent samples t-test table, and I have used them to write up this summary of the results in APA style. These call-out numbers on the left are simply used to identify sections of this write-up that I'm going to refer to later in this set of lecture notes. What does it say? The box plots in Figure 1 illustrate the distribution of health scores for the two groups of students. The mean health score for the not employed students, the mean was 5.60, standard deviation was 0.91. The mean health score for the not employed students was higher than the mean for the employed students. For the employed students, the mean was 5.33, standard deviation was 0.95. The observed difference between means was 0.26, and the confidence interval extended from 0.02 to 0.50. With alpha set at 0.05, the independent samples t-test indicated that this difference was statistically significant. T-statistic with 236 degrees of freedom was 2.16. Standard error was 0.12. The p-value was 0.032. Here is the box plot that we had just pasted as described earlier. My write-up of the results continues. As an index of effect size, Cohen's D statistic was computed by dividing the mean difference by the pooled standard deviation. This resulted in an effect index of D is equal to 0.28. 95% confidence interval extends from 0.02 to 0.54. A previous chapter, Lecture Notes 050 T-Test for Independent Samples, provided detailed explanations for the results produced from this type of analysis, so the current section will only provide a brief description of the results presented above, some of which I will talk about, some of which I won't. I'm on page 17 now, at the top of page 17. The third sentence of the first paragraph describes means and standard deviations for the two groups of participants. This is at call out 2. What am I referring to? 1, 2, 3. Here's the third sentence. The mean health score for the not employed students was higher than the mean for the employed students. And here I have means and standard deviations for the not employed group, means and standard deviations for the employed group. Where did that come from? It says these statistics were taken from the Jamovi output table headed group descriptives. Now, hang on, let's make sure we know what he's referring to. We scroll up. I'm on page 15 now. Oh, yes. Halfway down page 15, we have group descriptives. These are the mean scores that I referred to in the text. Mean for the not employed students was 5.60. The mean for the employed students was 5.33. Standard deviation for not employed was 0.91. Standard deviation for employed was 0.95. That's what I'm referring to. Let's scroll back down to page 17. In the same sentence, the observed mean difference and its confidence interval came from the table headed independent samples t-test. Now, what's he saying? Look for the call out number 3. Call out number 3, that's where I refer to the observed difference between means. I say the observed difference between means was 0.26. 95% confidence interval extended from 0.02 to 0.50. Where did that come from? We scroll up to the results of the t-test produced by Jamovi, and here it is. The mean difference was 0.26. What do you mean mean difference? Remember, that's the difference we got when we subtracted the mean score for the employed students from the mean score for the non-employed students. It resulted in a mean difference of 0.26. What's the confidence interval for that mean difference? It extends from 0.02 to 0.50. That is what I was referring to. Back to page 17. Did the mean difference part. On page 17, we look at the second bullet point. The last sentence of the first paragraph reports the obtained t-statistic, the degrees of freedom, and the attained probability value for the t-statistic. These values were taken from the table headed independent samples t-test below the headings statistic, degrees of freedom, and p respectively. Well, first, let's look at the excerpt from the article, the manuscript write-up in which I summarized the results. That's going to be somewhere around call out number 4. So back to my write-up. Here's my write-up. Call out number 4. With alpha set of 0.05, independent samples t-test indicated that the difference was statistically significant. T with 236 degrees of freedom was 2.16. The p-value is 0.032. Now, what are these values? First of all, what's this 236? That's the degrees of freedom associated with the t-test. Where did I find that? It appeared in the output for the t-test under the heading DF, degrees of freedom. Let's just take it one statistic at a time. This 2.16, it says t is equal to 2.16. What's that? That's my obtained t-statistic. Where did that come from? In the results from the t-test under the heading statistic. 2.16, that's my obtained t-statistic. Back to the manuscript. I didn't refer to this below, but we might as well point out what it is. SE is equal to 0.12. What in the world is that? SE stands for standard error. It's good form to report the standard error of the estimate when you're doing a t-test. The standard error is in my t-test results below the heading SE difference. That stands for standard error of the difference. 0.12, is that really what he reported? Yes, he reported 0.12. And finally, maybe the most important statistic to the typical reader, what is your obtained p-value? What's your obtained probability value? It's 0.032, and it appears in the results from the t-test below the heading P. Below the heading P, 0.032. So my obtained t-statistics, 2.16. The p-value is 0.032. This 0.032 is smaller than 0.05. It's smaller than our alpha criterion. That's how we know we had statistically significant results. Back to my write-up. Okay, we went through all the statistics that appear in this write-up. Back to page 17. Yep, call out number 4, these values were taken from the output below the heading statistic, degrees, freedom, P respectively. We continue. Last bullet point. Second sentence of the second paragraph reports the obtained value for Cohen's D statistic along with its 95% confidence interval. These were taken from the Jamovi output table headed independent samples t-test in the column headed effect size. What is he talking about? In the write-up, here it is, call out number 7. As an index of effect size, Cohen's D statistic was computed by dividing the mean difference by the pooled standard deviation estimate. I found this from the standard text on Jamovi, Navarro, and Foxcroft's text. This resulted in an effect index of D being equal to 0.28. Confidence interval went from 0.02 to 0.54. Where did that come from? Same table, independent samples t-test results, below the heading effect size. That's where we find Cohen's D statistic, which is the most popular index of effect size used as part of a t-test. My index of effect size was 0.28. Confidence interval went from 0.02 to 0.54. And that is what I wrote in this sentence. Cohen's D statistic was 0.28. Confidence interval went from 0.02 to 0.54. And that was my last bullet point. Here's a red font note for me and for you, the students. Psych 302 students, to save time, I will not lecture on the following section headed Guidelines, Reporting Results in the Text of APA-style manuscripts. However, you will need to study it because there'll be several items addressing it on your upcoming multiple-choice quiz. Use the study guide that appears in the current exercise for guidance. You do want to set aside time to teach this material to yourself. I have a section here that's headed Guidelines, Reporting Results in the Text of an APA-style manuscript. One of the most important things that the faculty in the psych department want me to do is to help you folks learn APA style. So this section of the chapter is going to be very important to study and get familiar with. As you know, your multiple choice quiz is open book, open note, but you've got to use your study guide and get familiar with these to be able to complete my multiple choice quiz in the time limit that I give you. So set aside time for studying this. Now, note to Hatcher. Skip to the red font note on page 24. We go down to 24, which is here. Page 24, this is not the very end of the chapter. What does this say? Psych 202 students, to save time, I will not lecture on the following appendix. However, there will be questions on your upcoming multiple choice quiz which ask things like, does your lecture note handout include a table that provides symbols for measures of central tendency? I want to give you a heads up that the items that you have on this appendix are not going to be difficult. They're simply going to ask, does Hatcher's chapter include a table that provides symbols for measures of central tendency? This is something that I hope will be useful to you in Psych 305 and in your lab classes. You'll be writing up results from an investigation, and you did a chi-square test, and you can't remember, oh, what's the symbol for chi? It's a Greek letter. To make things easier for you, I've created tables and included them in this appendix. This is what you'll find. Symbols for measures of central tendency and variability. These are the APA symbols that they want you to use. You do not need to memorize these. Remember, it's an open book, open note test. But I want you to know you've got a table that provides all these. And there's another table. Symbols for test statistics, like the F test and the Z test. There's a table that indicates what symbols are appropriate there. There's a table that provides symbols for correlation coefficients and R-family effect indices. There is a table that provides symbols for the D family of effect indices. These are effect indices such as Cohen's D statistic or first cousins to Cohen's D statistic, like Hedges' G statistic. Is there more? There is. Symbols for miscellaneous statistical terms. What's format that I'm supposed to use when reporting confidence interval? This is the general format to use. Is there more? I think that's about enough. It's a 30-page chapter, and this last appendix, you simply need to know what tables do I have there. In addition to being important for the multiple choice quiz, I hope that it'll be useful to you in future semesters. When you're taking courses, you need to write up your results, and you need a quick reference that shows you the appropriate symbols for various statistical concepts. And that is Lecture Notes, Chapter 055, APA Style for Summarizing Results in Text.